Think about it. Every culture in history has wrestled with the flow of time. Ancient myths spoke of gods who moved freely through past and future. Modern scientists, on the other hand, use mathematics and physics to explain how time might bend and stretch in surprising ways. In this video, we're going to explore how Einstein's theories changed our understanding of time, what wormholes might mean for traveling across it, the paradoxes that puzzle scientists, and the latest research pushing the boundaries of what we think is possible. So, could time travel be real? Let's find out. Before we can talk about time travel, we first need to ask a deeper question. What is time itself? To most of us, time feels like a straight line, a steady river that carries us forward from past to present to future. We measure it with clocks and calendars, and it seems absolute, the same for everyone. But physics tells a very different story. Albert Einstein discovered that time is not fixed, it is relative. This means the way you experience time depends on how fast you are moving and how strong gravity is where you are. Imagine standing on Earth while an astronaut travels through space at incredible speeds. For you, the seconds tick normally, but for the astronaut, those same seconds pass more slowly. This strange effect, known as time dilation, has been proven by scientists using airplanes, satellites, and atomic clocks. So in a sense, traveling into the future is not just possible, it's something that nature itself allows, and it's happening all around us, even if we don't notice. Einstein's theory of relativity not only reshaped our view of space, it completely changed our view of time. At everyday speeds, time seems stable, but as you approach the speed of light, something incredible happens. Time itself stretches. For example, if a spaceship could travel close to light speed for what feels like just 1 year to its passengers, decades might pass for people left behind on Earth. This isn't just theory, it has been tested. Scientists have flown atomic clocks on jets and compared them with identical clocks on the ground. The results were clear. The moving clocks ticked more slowly. This means time travel into the future isn't science fiction. It's a scientific fact. Right now, the effect is tiny because we don't move anywhere near light speed. But it proves that the laws of nature already allow us to step forward into the future. The only question is whether we'll ever have the technology to make those giant leaps in time a reality. But what about going backward in time? This is where things get really complicated. The laws of relativity open the door to one of the most fascinating concepts in physics: wormholes. These are hypothetical tunnels in the fabric of space-time, connecting two distant points with a shortcut. Imagine folding a piece of paper and poking a hole through it. That's how a wormhole could connect distant places, and possibly even different times. In theory, if one end of a wormhole moved differently in time than the other, stepping inside could let you travel into the past or far into the future. The problem? Wormholes are unstable. They would collapse instantly unless held open by a form of exotic matter, a mysterious substance with negative energy. So far, this exotic matter only exists in mathematical equations, not in laboratories. Still, the idea excites scientists because it shows that our universe doesn't completely forbid time machines. It only sets incredible challenges, like stabilizing wormholes or finding forms of matter we've never seen before. And as history shows, today's impossibility can sometimes become tomorrow's discovery. Even if wormholes or time machines existed, they would lead us straight into the heart of one of science's biggest puzzles: paradoxes. The most famous is the grandfather paradox. If you traveled back in time and prevented your grandparents from meeting, you would never be born. But if you were never born, how could you have traveled back in time at all? These logical knots make past-directed time travel difficult to imagine. Some scientists propose a radical solution: parallel universes. In this view, traveling to the past wouldn't change your own timeline. Instead, your actions would create a new, alternate timeline that branches away from the one you came from. While these ideas sound like science fiction, they are taken seriously by physicists because they solve contradictions. Still, there's no evidence yet that parallel universes exist. Until then, paradoxes remain one of the strongest arguments against traveling into the past. So what does modern science say today? Surprisingly, time travel is not just a thought experiment. In fact, our entire GPS system depends on it. Satellites orbiting Earth experience both weaker gravity and faster speeds than we do on the ground. Without correcting for these relativistic effects, GPS would be off by several kilometers every single day. In other words, time dilation is not only real, it's built into the technology we use daily. Physicists are also exploring whether certain particles might move faster than light. If proven true, this could open entirely new doors to understanding time. Other researchers are testing how extreme environments, like black holes, might warp time in ways we can barely imagine. Yet despite all this progress, no one has built a time machine. Most scientists agree that traveling into the past is unlikely, but traveling into the future is already happening in small steps, through the very fabric of space and time itself. So could time travel be real? The answer is both yes and no. Traveling into the future is supported by Einstein's laws and has been measured many times. Traveling into the past, however, remains filled with paradoxes, unanswered questions, and technological roadblocks. But science is always evolving. Just 100 years ago, space travel seemed impossible, yet today we send robots to Mars. The boundaries of science are constantly moving. Maybe in the distant future, humanity will discover materials, forces, or even entirely new laws of physics that make time travel possible. Until then, time travel remains a bridge between imagination and science. It's a reminder of how much we still have to learn about the universe, and how the questions we ask today may lead to the breakthroughs of tomorrow. So is time travel possible? For now we can say, into the future, yes, into the past, not yet. But the journey of discovery itself is just as exciting as the destination. And who knows, the next great leap in science might bring us closer to living one of humanity's wildest dreams. Once again, time travel remains a bridge between imagination and science. It's a reminder of how much we still have to learn about the universe and how the questions we ask today may lead to the breakthroughs of tomorrow. So, is time travel possible? And who knows, the next great leap in science might bring us closer to living one of humanity's wildest dreams. Considering subscribing on my channel, don't forget to subscribe, turn on notifications, and support the channel by clicking the join and subscribe buttons.